They give us two statements. We need to be looking for a couple of conclusions we can make what each one of those statements leads us to. And just start with the first one. BD bisects, so right down the middle, bisects angle ABC. So we're going to say definition of an angle bisector. If you're not sure the conclusion, maybe pause the video and go see what we're going to make, or go see what that leads to. We should have a couple angles the same. So which angles? Well, measure of angle 3 and measure of angle 4. Measure of angle 3 and measure of angle 4 are going to be the same. Okay, what about the second statement? So we've used that. Angle 3 and angle 4 complementary. Well, what does it mean to be complementary? Do we have a theorem for that, a definition? Again, if you need to pause, go look for it first. That might be a good idea. Definition of complementary angles. What does it mean to be complementary? These are measures have a sum of 180, and the conclusion is just that. Measure of 3, measure of angle 4 have a sum, if you add them together, of 180 degrees. Those are the couple things that they give us. Those are the couple equations they lead to. Is that enough, or do we need to look for more? Do we have something we can replace already? Well, you see what we're trying to prove? Sometimes when you're not sure, look ahead now at this point. What are we trying to get to? We want a relationship with just measure of angle 3. Right now I have relationships with 3 and 4 in both of them. But 3 and 4 are the same, so they can replace each other because their measures are equal. What I'm going to do is I'm going to take this second equation and I'm going to replace measure of angle 4 with measure of angle 3. That gives me a relationship with, oh well, you guys caught me and were wondering when I was going to change that. Complementary doesn't mean they add up to 180. It means they add up to 90. Should I remake the whole video? Be a whole 2 minutes? Well, I think you guys will forgive me. Should be 90 degrees. Sorry about that. You can tell by our picture too, it can't be 180. But so, instead of having measure of angle 3 plus measure of angle 4 equal to 90, we'll do measure of angle 3 plus measure of angle 3 equal to 90. What do? We just replaced. So we'll justify it with our replacement rule. Well, 3 and 3 equal 90. You kind of know that's going to work, but how could you formally prove that? What could you use to justify that? I think this is the first time this has come up, but it'll start coming up more and more. So maybe next time you'll think of this on your own. But right now, what's x plus x? Think of it like that, and I can even do that off to the side. If we had x plus x equals 90, wouldn't that be 2x? You know, and if we were still doing algebraic proof, I'd probably do a 1x plus a 1x and show you that we can factor out the 1 using our distributive property. And we could prove it much more specifically and get 2x equals 90 using some factor of arithmetic. So we've done some algebraic proofs where we'd be a lot more particular than that. But that was because our audience was for an algebra student. If you're doing a geometric proof, you don't have to show all that algebra. So you can say x plus x equals 2x, or the measure of angle 3 plus the measure of angle 3 equals 2 of those. And that's just a fact of algebra. You don't have to show combining like terms anymore. Why, and explain why we can do that. Just say, no, that's just combining like terms. That's some algebra. So we have 2 of them. And maybe you have an idea how to get here, because we have used this property, not as often, but we have. What says that if 2 times measure of angle 3 equals 90, that 1 measure of angle 3 equals 45? What are we really doing to get that? Well, if you had 2x, go back over to the side here. If you had 2x equals 90, how would you get to x equals 45? You'd be dividing both sides by 2. That's what we're doing here. So what property says you can multiply or divide both sides by 2? MPE, multiplicative property of equality. Multiply or divide both sides of an equation by 2. We know that the measure, and have proven formally that the measure of angle 3 would have to be 45 degrees.